Okay, we're ready for lesson 5. The title of this lesson is Definition of Rotation and Basic Properties, and so that's exactly what we're going to look at. So a rotation is going to be the third type of transformation in the plane that we're looking at. The first two were, let's look here, the first one we looked at was translation. And remember, for translation, we needed a translation vector, and it told us two things. It told us where to slide the figure to. It told us how far. So the length of my vector tells me how far. So I'm going to translate this triangle along vector AB. And so let's trace my triangle too. So this triangle is going to slide, and it's going to slide in the direction of the vector. So this is how I do a translation with a vector. So my image here, this is my image. Every point on that triangle moved the same distance in the same direction, so it didn't change the shape or the size of the image under the translation. Okay, so you've been practicing with those, but I think those were maybe the trickier than reflections, which is our next type of image that we did. So we've got, this would be a reflection. So let's look at that. For a reflection, I'm not given a vector, I'm given actually a line of reflection. And you could think of that as basically your mirror almost. So I have line L that I'm going to reflect triangle ABC around, or about, you could say, okay? So there's A, B, C. And to do that reflection, I flip. I'm going to mark a point on my line just so, because no point, let's mark point P. No point on that line of reflection is going to move because it's going to flip over and line back up. Oh well, I didn't mark it on my paper, but you get the point. So there's my image. So there's the image of triangle ABC. And you know, this would be point A prime, point B prime, C prime. And the reflected image is the same size and shape, so this type of transformation preserves distances and angles just like a slide does. Okay, so that's just to kind of recap what we've looked at so far. But I want to go back to that original example that we had of these figures here. And you were asked to find a transformation that would map one of the figures onto another. And we found out that for this particular one here, that a slide didn't work. Doesn't matter what direction we slide it in or how far, it's not going to match up. And neither did a flip. I can flip my paper over, and you can see that no matter where I reflect around, that's not going to work. So we need another type of transformation in the plane, and that's where our rotation is going to come in. Okay, so let's look at our first example here, example 1. And example 1 shows a point rotating. Point P is going to rotate from its original location to point to its image, P prime. And so for a rotation, you need to be given the point around which to rotate. So we're labeling that point O in this diagram, and we're going to rotate point P 30 degrees. And so you can see its image under that rotation. So that's in a counterclockwise direction. We're going to call that positive 30. But we can go the other direction as well. And we would call that rotation negative 30 in the clockwise direction. And that's just a convention that mathematicians have agreed upon to use. Okay, so what I'd like you to work on now is Well, let's demonstrate a rotation first using your transparency, and then I'll let you do the exercises. Okay, so before I set you off on exercises 1 through 4, let me just demonstrate how you can use your transparency, and we'll look at example 1 to do that. So example 1 shows us the center of rotation, which is right here. That's our point O in this diagram. And we're going to rotate point P a certain number of degrees. And so I'm going to draw the ray or the segment here. And you're going to see that actually becomes almost the radius of a circle. And we're going to go 30 degrees. So I'm going to hold point O in the same place and rotate over to the image P prime. So we've done that. And if you look over here, I'm going to line it up with, here's my original again. And if I rotate negative 30 degrees, that means I'm going clockwise. And I'm going to end up at P prime right over here. Now, what's the maximum rotation that I would even want to think about going? So let's go in the counterclockwise direction. So we're going positive, and I can keep going. A bigger rotation, and see my images moving around the circle. And when I end up back where I started, I've gone all the way around the circle, which would be 360 degrees, right? So the maximum rotation would be 360, and then I could do the same thing in the negative direction. Can go all the way around and end up back at my starting point would be negative 360. Okay, so your degree of rotation is going to be somewhere between negative 360 and positive 360. Okay, so I think you are ready to do exercises 1 through 4. So go ahead and do that, and then we will correct those together. So pause the video, do exercises 1 through 4 using your transparency, reading the directions, and then we'll correct those together. Right, exercise 1 tells us that we're going to rotate point P a certain number of degrees around center O. So P is labeled here for you, and we're told in this case to make D, our degrees of rotation, greater than 0. So that would mean we'd be going in a counterclockwise direction. And just a side note, the reason for that, which seems kind of backwards, the reason for that is because we're going to be doing these rotations on the coordinate plane. And if you remember the naming of the quadrants, this is 1, this is 2, 3, and 4. Quadrant 1, 2, 3, and 4. And that's the way the coordinate plane is laid out. So really rotating in a counterclockwise direction is going around the plane in the way that we want to go. Okay, so in the direction of the quadrants. So that's a reason for you there if you're trying to remember what's the positive direction and what's the negative direction. Okay, so I'm going to trace, just real quickly, I'll do this for you. You've already done it, of course. And so I get to choose my number of degrees, and I'm going to rotate counterclockwise because my degree of rotation is positive. I don't need to do any particular amount, so I could go further or closer. I'll go about right here. And then I'm going to trace my point is right here. And so this would be P prime, and I can draw the segment that joins it as well. Okay. All right, so that would be exercise 1. Let's look at exercise 2. Exercise 2 tells us to do the same thing, only this time D is less than 0. So we're going to do, sorry, that wasn't on there. So D is less than 0, so I'm trace my points, point P, point O, and I'm going to rotate clockwise this time. So I'm going to go way down here. So there's my rotation. Point O didn't move, point P did. So there's P prime. I'm going to connect it with the radius, and then we should have labeled this is D. There's my degree of rotation there. So there we go. So let's talk about 3 and 4. So which direction did the point P rotate when D was greater than 0? This would be counterclockwise. Positive rotation is counterclockwise. And a negative degree of rotation would be clockwise. This would be to the left. This would be to the right. Okay. Okay, so we think, before we go on to the next couple exercises, let's talk about a few things. So if you think about this point P rotating around this center O, you've probably noticed already that these, they end up being on the circle, on a circle here. So here's P, and O, if I rotate this, and I'm going to draw the radius here, if I rotate to different locations like that, so there's a P prime, every one of those is going to lie on the circle. So that's a feature of rotations, is that the points, the images will always be equidistant from the center. So if this is a P prime right here, this radius R doesn't change for any given circle. So it's always going to be, the image is always going to be the same distance from the center of rotation. So one other thing that we will make a lot of use of is the fact that if I rotate 180 degrees about this circle here, I'm going to draw the radius too. If I go 180 degrees, what does that mean? Well, 90 would be 1/4 of the way around the circle, right? And then 180 would be halfway around the circle. So let's label that P prime right there, P prime. And that is rotated, well, let's get rid of this one. That's rotated 180 degrees. That's a 180 degree rotation. But you might notice that it's also the same as a negative 180 degree rotation, right? So if I have that point there, my point P, and I go in the clockwise direction, 180 degrees, I'll line up at the same point. Another feature of that is that with 180 degree rotations or negative 180 degree rotations, the points will be on the same line. P, O, and its image P prime will all be on the same line. Okay, so that's another important point about that. Okay, let's do one more example here. Been rotating points, but we can rotate figures and we can rotate line segments. So real quick, let's look at this. We have a line segment right here, and we have our point of rotation on the line segment. I'm going to draw another point up here, and then a couple other points. So we're going to be rotating this collection of points, this line segment, and points around some amount of rotation will go positive around point O. So we'll rotate it, looks like about 30 degrees over here. So here's, let me draw the images of these points. So we've got this one, and that one, and that one. Okay, and then I'll go ahead and connect my line segments this way. Use my straight edge here. So that's the segment. So you can see here's my original figure with the line segment and 2 points. Here's my rotation in green. And what you should be able to notice is that all the distances are preserved. So the distance between these 2 points is the same here and here. The distance to the line and anything within the figure, all the distances have been preserved in this rotation. Okay, there is an online gadget, just like the one, if you looked at the one for translation and reflection already, there's one for rotation. So I'm going to go ahead and insert that here in this video, and you can look at that and you can play with it yourself if you go to the website address. All right, now we're going to go back to that example, our little picture from lesson 1, and that we talked about at the beginning of this lesson, and said that we couldn't do a reflection or a slide to make these two figures coincide or be exact image of each other, be mapped onto one another. But we can do a rotation now. So let's look at that, and kind of given this away, but maybe you had played with it already. But if my center of rotation is out here, right here at O, these figures will rotate onto each other. And so if I go, let's look at what happens. This is my original, so I'm going to trace it down here. If I take my original and I rotate it around, my red in there, let's look at what happens. So I'm going to go in a let's see, let's go counterclockwise. Let's go clockwise. If I rotate like this, you can see the image mapping, or you see where it ends up. So that would be a 90-degree rotation. Actually, minus 90. And if I go here, once again, you can see where the image ends up at 180 degrees. And then once again, right here, it maps right onto that other image. So in 90-degree increments, you can see where this image ends up. And it can be, doesn't have to be a 90-degree increment. It could be right here and like that. And if I wanted to do it, what number of degrees would map it directly? Well, if I'm going counterclockwise, if I go counterclockwise exactly 90 degrees, then it would map directly. So that would be a 90-degree rotation would map our original onto its image. Okay, so sometimes it's kind of tricky to see where that center of rotation would be. We could rotate it around different points like this, but that would never get me over here. So mapping it around, rotating it around that point is the ticket, is what's going to get me there. All right, so I think you're ready to play. So you can get out exercise 5 and 6. In this one, let's go ahead and read it. I'll read it with you. Let L be a line. So L's a line right there in the middle. AB is a ray over here. CD is a line segment. And then we've got an angle over here. We've got angle EFG. And there's a rotation of d degrees around point O. So where's point O? Okay, well, it's right over here. So here's my point O. So notice it's not on a line anywhere. It's just point O. And we want to find the images for all these figures. And we want d to be greater than 0. So you have to think about d greater than 0 means a counterclockwise rotation. And you get to choose the amount of degrees. And so all you're asked to do is just do this and find the images there. Okay, and then in exercise 6, you've got a segment AB, an angle EDC or CDE. The angle is about 45 degrees. You can measure it with a protractor. And then you have a rotation, a negative rotation, so think about what direction that's going. And then you're asked to find the images, got flies in here, find the images of the given figures, okay, and then answer the questions that follow. So there's my center of rotation, point O. And O, they're using O, and you could think of O for origin. Origin on the coordinate plane is a common point to rotate around. All right, so you're going to be asked what the length of the rotated segment is and the degree of rotation. So go ahead and do those, pause the video, work on those, and then we'll come back together and you'll be ready for your exit ticket and problem set. Now let's look at the answer to exercise 5, or the results you should have gotten. So I've drawn this on a transparency. I've been told to, so I traced everything. I traced my line, angles, segments, rays, everything. And I'm going to rotate around this point. And it kind of helps just to hold the paper down right here and rotate. Now I'm going in a counterclockwise direction because my directions said that my angle of rotation was greater than 0. So that means I'm going counterclockwise. If you went this way, then you didn't follow directions, because that would be clockwise, would be a negative degree of rotation. So you should have come somewhere over here. It's up to you how much to rotate. And then just, lifted up your overhead and traced the points. So there would be A prime, B prime. Okay, come over here. Now notice my degree of my point of rotation should not have changed, because that's the whole idea. There's my L prime right there. And then I have my segment CD. So there's D prime, C prime, and there's angle G prime, F prime, and E prime. Okay, so your paper should look similar to mine. You might have rotated it a little further, not quite as far, but that's the basic idea. So let's look at 6, sorry. Exercise 6. We had this set of figures, and we're rotating in our directions say to rotate let D be less than 0. So that would be clockwise. So I'm going to go clockwise just a little bit here. And let's go far enough to get them like that. Okay, so I could come in here. So that was clockwise. So I have, or you could have gone really over here. Let's go there. Okay, so it's up to you. You get to choose. So there's E prime, C prime, and D prime. And there's, let's make sure O is matched up. There's B prime and A prime. Okay, so I'm going to draw my angle here. There's D prime. This would be C prime and E prime. So there's my angle and my segment there. Okay, so your paper should look something like this. And we're asked in part A and B, what is the length of the rotated segment? Well, my intuition tells me that it's 4 units because my original was 4 units, and rotations are going to preserve distances in the figures, and they also preserve angles. So this angle over here will also be the measure of rotation. Angle CDE is 45 degrees. They should be equal. So rotations are going to map angles to angles. They're going to map line segments to line segments, lines to lines, points to points, just like translations and reflections did. And then it preserves distances and angles within the rotation. Okay, so this last exercise, I actually lied. There is a number 7 and 8 that we're going to do before you move on to the problem set. And we're going to look at what happens to parallel lines in a rotation. So here's a rotation around point O, and you've got line 1 and line 2. And let's see what the directions say. Lines 1 and 2 are parallel. Let there be a rotation by d degrees, where d is somewhere between negative 360 and 360, so you get to decide on this one. And then you're going to be asked, is L1 prime, or L1 prime and L2 prime also parallel? All right, and then in 8, we've got a center of rotation again and a line. And we're going to rotate that line by d degrees, where d is not equal to 180. So you can choose any degree of rotation except for 180. And then you're asked, are the lines parallel? Okay, so turn off the video, do that, come back, we'll quickly talk about it, and you'll be ready to go. All right, so what you should have noticed as you rotated this pair of parallel lines in exercise 7 about this point O is that no matter the degree of rotation, this becomes now, and you could trace it on your paper to better do this, but this is L1 prime and L2 prime. They stay parallel to one another. So the question, is L1 prime parallel to L2 prime under this rotation? Yes, it is. So parallel lines are going to be mapped to parallel lines. But let's look what happens in exercise 8 is we have our line and our point of rotation, and we're told to rotate it some number of degrees except for 180. And we're asked, is L, so here's L prime under that rotation. And we're asked, are the lines L and L prime parallel? And the answer to that would be no, they're not. The only way is if I rotate it a full 180 degrees, then I might get them, well, actually it has to be somewhere else. But yeah, so not 180 degrees. Let's just do that. If I go 180 degrees, what happens? I get it right over here, and those two lines would be parallel. So 180 degree rotations are special, and we'll do a whole lesson on those. Lesson 6 is on rotations of 180 degrees. So, but if it's not 180 degrees, the answer to this is going to be no. The lines will not be parallel. And you could go around the circle all the way to prove that to yourself. Okay, so I think you are ready to go on to your problem set. So let's look real quick together at the lesson summary right here. So we've already talked about this, so I'm going to go quickly. Definition of rotation comes first. We need a center of rotation, and we need to know the degrees which to rotate. And some basic properties would be that rotations map lines to lines, rays to rays, segment, and so on, angles to angles. Lengths of segments are preserved in a rotation, and degrees of angles are preserved in a rotation. When parallel lines are rotated, their images are parallel. We saw that in exercise 7. And a line is only parallel to itself when rotated exactly 180 degrees. Okay, so go ahead and do the exit ticket and problem set, and we'll be back tomorrow for lesson 6.